Hey, listen, if you are looking for the mathematics prelims, paper one, then you came to the right place. My name is Fikakahle Manana, and I will be going through this paper with you right now. Well, let's get right into it. Question one. Let's go for 1.1.1. So here we are given 2x plus 1 in a bracket and it's squared minus 4 is equals to 0. Well, the first thing that we have to do is expand this. Now in expanding this, I like to open two brackets because it's very easy to make a mistake. And now that you are in matric, there is no time for mistakes. You have to be absolutely clinical in your calculations. So first of all, it's 2 times 2, which gives me 4, right? And then it's x times x, which gives me x squared. The next one, it's 2 times 1, which gives me 2, and then x times 1, which just gives me x. And then the next one, it's 1 times 2, which gives me 2, and then 1 times x, which gives me just an x. And the last one, it's 1 times 1, which gives me 1. Now, I've dealt with the bracket. Don't forget the minus 4 right over there. That's equals to 0. Right, now let's put things together. I've got 4x squared, 2x plus 2x, that's plus 4x. 1 minus 4, that's minus 3. That's equals to 0. Now at this point, I don't want to waste any time. I just go straight into the quadratic. And if you don't know the quadratic formula, well, it's okay. But in matric, you should know it by now. It's the first formula they give you right over there. See, I'm highlighting it with red so that you could see it. That's the formula right there. So we know that x is going to be equals to minus b. Okay, let me just put the letters for you real quick. That's going to be A, that's B, and that's C. Now, when it comes to these letters, I like to put them in brackets. Okay, so B is 4, right? And then plus or minus, I'm just following the quadratic formula. B squared, B once again is 4 squared minus 4a, I put it in a bracket, it's 4, and then c is minus 3. You have to be careful to put the negative sign as well. Okay, divide everything by 2, and a is 4 once again. Now once you have that, put it in a calculator. There we go. I got this calculator. I call this calculator the Porsche calculator because it can do many things. Okay, so we got a negative, open bracket, put it exactly as I wrote it. Close that bracket. We'll start with the plus. We open the square root, open a bracket, put a 4, close it, and then square it. And then say minus 4, open the bracket again, put the 4, close it, open another one, put a negative 3, close it. Then let's go downstairs. 2, open a bracket, 4, you close it, and then you say equals. You will get that x is equals to a half. That's your first one. Or now what we have to do is go back to our equation right there and remove this plus, delete it, we put a minus, and then equals, or x is equals to minus 3 over 2. Well, that's it. These are our two answers right there. There's no need to check them. You just leave it like that. Okay. Well, now I would like us to actually move on to the next question, right? We're still in question number 1. And just to use a different color because I like using different colors, right? So let's go 1.1. 1.2. We've got 4x squared minus 11 is equals to minus 12x. Well, just going to rearrange this. 4x squared. I'll put it in the normal order. This minus 12, I'll bring it on the other side so that it becomes plus 12x, and then minus 11 stays on this side. Okay, so once again, that's A, that's B, and that's C. Okay, let's go back to our quadratic. Highlighted it here. There we go, it's red. So I'm just simply gonna say minus, once again, what's B? The value of B this time is 12. Okay, plus or minus square root B squared. B once again is 12 squared minus 4. What's the value of A? It's 4. The value of C, it's minus 11. Make sure you put that minus there. Okay, it's very important. Okay, so now all of this is divided by 2a. The value of a is 4. Okay, so right about now we need our calculator. There it is. Start with the fraction, put a minus, open your bracket, put a 12 in there, close it. Start with a plus, we open the square root, and bracket once again, put 12, close it, square it, minus 4, open it, okay, close it, open another one, and then put in a minus 11. Right, close that, and then go downstairs, put a 2, open it, put a 4, close it, equals. Now it gives you this thing, right? But we want it in decimal form, 2 decimals. So this becomes x is equals to 0.7. Because there's a 6 there, then this 3 becomes a 4. Okay, or let's go back there. All right, let's go upstairs, go to the side. Then we remove this plus, delete it, put a minus there. What do we get? We want it in decimal, or x is equals to 3. There's a minus 3.7. There's a 6 there, so that 3 becomes a 4. Right, now these are your two answers right there. Full marks. Full marks for these questions. Well, thank you so much. Let's move on to the next question. And listen, once again, please take a moment to subscribe to our channel if you haven't already done so. All right, otherwise let's get into 1.1.3. We are given 15x minus 4, okay, is less than 9x squared. Okay, so what I'm gonna do is just rearrange, bring the 9 this side, it becomes minus 9x squared plus 15x minus 4 is less than 0 now. Let's just go right straight into the quadratic equation. So that's gonna be A, B, C. Hey, we're using the quadratic equation a lot. Okay, I know it. It's minus b, and b is 15 plus or minus square root of b squared. B is 15 squared minus 4a. A is minus 9. And then C is minus 4. Right. Close that bracket. Square root divided by 2a. And what's a? A is minus 9. Okay, let's see what the calculator is going to give us. Put that. open the bracket, 15, close it, start with the plus, square root, open the bracket, 15, all right, close it, square it, minus 4, open it, there's a minus 9 there, close it, open it, there's a minus 4 there, close it, go downstairs, 2, open it, minus 9, close it, equals. Okay, so we have 1 over 3. Let me just put it in decimal. Okay, no, it's fine. Let's leave it as a fraction. Go back upstairs to the side, delete the plus, put a minus, and we get 4x is equals to 4 over 3. Now, which one is bigger? 1 over 3 or 4 over 3? Huh? 4 over 3 is bigger. Okay, that's all we need. So at this point, I've got our critical values. Okay, so these are our critical values. I'll call them CVs for critical value. And what I like to do is draw a line. Okay, this represents the positive side and that represents the negative side. And now our graph, just looking at A is negative, which means our graph is shaped like that. Okay, and these are our critical values. I've got 1 over 3 there, and then I've got 4 over 3. That's all I need, the critical values right over there and there. Now, according to this inequality, I'm looking for where the graph is less than 0. Less than 0, which means the negative side. Okay, I can see that on the positive side, I have this bulging part, but on the negative side, I have the graph from negative infinity to 1 over 3 and from 4 over 3 to positive infinity. How do I write that? Well, my answers are, sorry about that, x is, well, from negative infinity is less than 1 over 3, right? And x, values of x that are more than, okay, 4 over 3. These are our answers, right? Okay, there we go. We are done. Okay, let's look at the next question. There we go. 1.1.4, right? 1.1.4. And we've got a square root of 2x minus 2, right? All of this under square root minus another square root of 7 minus 2x. Okay, and all of this is equals to 1. Now remember, the whole idea with these questions is to put the surds on one side and then put the numbers or whatever else is left on the other side of the, equal sign. It's already done here, so we can just go over and put the brackets in square on both sides. Okay, now when we do this, remember what I like to do? I like to actually open 2 brackets. Okay, so that we avoid confusion, so that you can literally see, because remember in metric, there's no time to make mistakes. Your precision must be spot on. Okay, so doing this makes sure that your precision is really, really spot on. I know it looks like it's taking time, but trust me, it's well worth it. Okay, so 1 squared is just 1, so that's cool. Right, now if you multiply this and that, what do you get? Square root and square root, you just get the thing, 2x minus 2. Now if I multiply it with that, I'm gonna get, first of all, it's negative, so I'm gonna get that square root of 2x minus 2 times that square root of 7 minus 2x. Okay, I'll just leave it like that. Now I'll multiply this with that. What do I get? It's minus once again, so it's minus. I'll rewrite it exactly like this, so that I'll start with the 2x minus 2 times, okay, the 7 minus 2x, okay, under the square root. And then that last part, this and that, I will then get, first of all, it's going to be positive. Square root and square root of the same thing, you get the very same thing, 2x. All this equals to 1, right? Okay, so what do I do now? I am going to take all the 2x's. So I've got 2x here, and this one. They subtract each other, so I'm left with 0. Now let me take the numbers. I've got minus 2 right over there, and minus 2 plus 7. Minus 2 plus 7, I get plus 5. And then I want to take that number as well, bring it this side. Plus 5 minus 1, I'm left with a 4. Now, these ones right over here, these middle ones, these square roots, what I'm going to have here is actually, I'm going to have, first of all, it's minus, and there's 2 of them, so I'll go 2. And I can actually put everything under the square root. Okay, so under the square root, I'm going to have, just to do it step by step, 2x minus 2. I just simply remove the square root, and then this is actually, let me put it in a bracket, multiplied by 7 minus 2x. Right, so they share a square root, these two terms. Okay, all of that is now equals to 0. Now let me multiply it in. Okay, so I'll have 4 minus 2 square root. Okay, the first one is 2x times 7. Okay, so 2x is 14x, right? And then once again, 2x times 2x. First of all, it's negative, so 2 times 2 is 4, and x squared, right? And then the next one is minus 2 times 7, which gives me a minus 14, and then a minus 2 times minus 2, I get a positive 4x. Forget that x. So remember, all of this is under a square root, still equals to 0. Now what I want to do is simplify, but first I'll take the 4 to the other side, and I'll be left with minus 2, and then the square root. Now let me simplify this one. It's minus 4x squared, right? And then 14 plus 4 is a plus 18x, which is taking the x's together, and then minus 14, which is what I'm left with. Right, all of this is equals to minus 4. Why minus 4? Because I just took this 4 to the other side. And then the next part is to divide both sides by minus 2. Okay, so if I say divide by minus 2, divide by minus 2, what I'm left with is the square root of minus 4x squared plus 18x minus 14 Remember, this is all under a square root. It's now equals to 2. Right. Once again, I have a surd on one side and a number on another side, which means I can go ahead with my brackets and square. What I do on one side, I do on the other. And then if I do this, now it just simply gets rid of the square roots. I no longer have 2 square roots, I have 1 square root. So everything just falls off. Minus 4x squared plus 18x minus 14 is equals to 2 squared is 4. Finally, I'm going to have minus 4x squared plus 18x minus 14. And then if I bring this 4, it becomes minus, so it becomes minus 18 is equals to 0. If I bring the 4 to the other side. Okay, cool. Yeah, remember we're solving for x, so I'll use a quadratic once again. That's a, that's b, and that's c. So minus b is 18. Okay, plus or minus square root of b squared, which is 18 squared, minus 4a is minus 4, and then c is minus 18. Right. Okay, all of this under square root divided by 2a. 2 times a is minus 4. Okay, let's bring out our calculator. There we go. Put a minus, open bracket, 18, close it, start with the plus, put that square root, open the bracket, 18 once again, close it, square it, minus 4, open a bracket, it's negative 4, close it, open it, minus 18. Right, close it, then go downstairs, 2 minus 4, close it, what's that equals to? Oh, there we go. So x is equals to 3 over 2, or, right, let's go back, go upstairs, let's go upstairs to the side. Okay, there we go, delete that, put a minus there, and an equal sign, or x is equals to 3. Now, when it comes to surds, you have to do a check. Okay, and how do we do a check? Basically, we just substitute into the equations the values of x, because with surds you have to reject one of them if it's not relevant. So the first check we'll do is if x is 3 over 2, so we'll go back to the surd. Let's see if it will give us 1. So we've got 2 times 3 over 2 minus 2, that's under a square root, minus, okay, 7 minus 2 times 3 over 2. Okay, for this x value to be valid, it must give us 1. So let's see, open the bracket, and you say 2, open the bracket, 3 divided by 2, close it, minus 2. Okay, go to the side and say minus square root 7 minus 2, and then we've got open the bracket, 3 over 2, close the bracket. What answer does this give us? Ooh, this is not 1. This is not 1. It gives us minus 0.58, which means we must reject this one, this x value. So x is not equals to 3 over 2. Okay, let's do this very same check with the 3 now. So we've got a 2, put a 3 minus 2, Okay, minus 7 minus 2, and then put a 3. If this gives us a 1, then it is valid. Okay, which is cancel everything. 2 times 3 minus 2, and then we go to the side, we say minus square root of 7 minus 2 times 3. Look at that, it gives us a 1. Okay, so that's our answer, rejecting 3 over 2, and we accept 3. All right, let's look at 1.2 now. And 1.2, solve the following equations simultaneously. Okay, I'm given that, and I'm given the log. Okay, I've got A and I've got B. Okay, let's start with the log. Let's start with the log. So given log 2 as a base, and then I've got A plus 5 is equals to 3. Now we have to convert this to an exponent. Remember, the base of the log, which is 2, is also the base of the exponent. Then you interchange these two. So the 3 comes on top to complete the exponent is equals to A plus 5. Right? See everything in the bracket. Or let me leave it in the bracket so that you can see it clearly. Okay, so now I've got the situation. It's easy to calculate for A. So this becomes 8 is equals to 1 times A is just A. I'm getting rid of the bracket now. Plus 5. Okay, cool. So I just simply take the 5 to the other side. It becomes negative. Therefore, my A is equals to 8 minus 5 is 3. Go ahead, underline it. That answer is complete. Now I need to solve for B, right? I have my A is 3, so for B I'll just substitute into this equation right here, which is, let me just rewrite it. It's A squared B squared minus 2 times AB minus 8 is equals to 0. That's my second equation. Now I have the value of A, so I just substitute it. So it's 3 to the power 2 B squared minus 2 times 3B minus 8. Remember, the whole idea is to solve for B. So what is 3 squared? 3 times 3 is 9. B squared minus 2 times 3 is 6. And then B minus 8. What I have now is a quadratic. My goodness, I'm using the quadratic formula over and over in this exam. Once again, identify A, B, and C, right? So it's minus B, which is minus 6 squared, plus or minus square root of B, which is minus 6 squared minus 4A, which is 9, and then C is minus 8. Wow, this exam required you to know a quadratic and use it extensively. Okay, so AC, right? Okay, let's bring out the calculator now. So calculator, we've got a minus, open the bracket, minus 6, close it. Why did I put a square there? There is no square, my bad. There's no square there. Okay. Plus, you must watch out for these little mistakes you make under pressure. Okay. Just make sure you correct them. The square is right there. Cool. Minus 4, open the bracket. 9, close it, open it. Put a minus 8. Close it. Go downstairs, put a 2, open the bracket, 9, close it. It's equals to. So now I have that b is equals to 4/3, or okay, let's go back to the equation, go upstairs, go to the side. Okay, remove that plus, put a minus, and or b is equals to -2/3. Do we need to do a check here? No. The only time we do checks is when we have a surd. No surd here, straightforward. Those are the values of. Okay, let's look at the last question now, which is 1.3. It says p is equals to that. For which values of x will p be real? Okay, let me just write it. P is equals to the square root of x plus 2 all over square root of 16 minus x squared. Okay, so there are a few things you need to understand about real numbers. It's either they give you 0 or a positive number. Okay, so let's look at these surds here. If let me just put the conditions on top here. For it to be a real number, it's either 0 or a positive number. It can't be a negative number, then it won't be real. At the bottom here, it cannot be 0, because if you divide by 0, any number divided by 0, it becomes undefined. So it can't be 0, it just has to be a positive number only. Right, so let's take these conditions and put them individually. So under the surd, okay, it has to be x, right, plus 2. This has to be, for it to be a positive number, it has to be greater than 0. But for it to be 0, it has to be equals to 0. So we will then put the equal inequality. So there, I'm just going to take the 2 to the other side. Then x just has to be greater or equals to -2. Okay, we've just dealt with the top. Remember, these are conditions for the surds. At the bottom, it has to be 16 minus x squared has to be greater than 0 to show that it's positive. You don't put an equal sign, because equals to 0, it will be undefined. So I'll just take x to the other side. So I've got 16 is greater than x squared. Now I want x on its own, square root both sides, and then I get that the square root of 16 is plus or minus 4. That's greater than x. Cool. So let me put this into perspective. I have to combine both of them. I've got two x values. So what I'm going to do, I'm going to say x. First of all, let's start with this one. X has to be greater or less than -2. So I can rewrite that like this, then -2. Okay, and then x here has to be less than let's say let's take the +4 one, because if I take -4, then it's on the other side of -2, which is not true. So x is less than +4. That's my final answer. Well, yes. Please like and subscribe to our channel. This is the end of question 1. Let me see you on question 2 now. sorry about that loud advert, but gotta pay the bills, right? Anyway, let's move on to question 2.1.1. It says the following is an arithmetic sequence. Okay, arithmetic. We know that in arithmetic, D is equals to term 2 minus term 1, which is also equals to term, how many terms I got there? Term 3 minus term 2. Right. Okay, we know that part. Now it says calculate the value of P. We're just going to follow this situation here. We already know that term 2, that's, okay, let me just highlight it for you, right? Let's go yellow. That's term 1 right there. Cool. And then term 2, that's term 2, right? And then the one that's left, that's gonna be term 3. Let's go sign. That's gonna be term 3. Cool. So we come here, term 2, just follow that. Term 2 is 2p minus 3, and then minus term 1, I put it in brackets. It's 1 minus p. This should be equals to term 3. Term 3 is p plus 5 minus, put it in brackets, term 2, which is 2p minus 3. If we do this, what we want to do is expand this first. So we'll multiply that into there. But first, let's write 2p minus 3 minus 1. Remember, there's an imaginary 1 there. Minus 1 times 1 is minus 1. Minus 1 times minus p is plus p. That's equals to p plus 5. Remember, there's a minus 1 there. So minus 1 times 2 is minus 2. And then minus 1 times p is just p. And then we have minus 1 times minus 3, which is plus 3. Now what I want to do is put all the p's on one side. Those are the variables. Then put the numbers on the other side. So on this side, I have 2p plus p, okay? And then this p, if I take it to the other side, it becomes minus p. That one, it becomes plus 2p. And that's going to be equals to 5 plus 3. And if I take this minus 3, it becomes plus 3 again. And then this minus 1, it becomes this side plus 1. Okay, now I know we can do this in our heads, and we probably should in metric, but I'll just use a calculator. So it's 2 plus 1 minus 1 plus 2. That's for the p's, right? So I get 4p. That's equals to this side. I've got 5 plus 3 plus 3 plus 1. And I got 12. Right. Now what's 12 divided by 4? That's equals to 3. So that's it. That's our final answer. Right. So 2.1.2 this time. It says write down the value of the first term of the sequence. Okay, that's A. Now the first term is 1 minus p. 1 minus p, and we just solved what p is. So it's 1 minus 3. So term 1 is therefore equals to, what is it equals to? 1 minus 3. I don't have to use a calculator. Just know it's minus 2. Okay. And then the next one, which is part B, right? The common difference. Now for the common difference, as you can see, that it's either T2 minus T1 or the other one around. So now that we have T1, let's solve for T2. So T2 would then be equals to 2p minus 3, right? So 2 times 3 minus 3. 2 times 3 is 6 minus 3. So T2 is just simply 3. Now for the common difference, we're going to say T2 minus T1. T2 we know is 3 minus, and T1 we solved it to be what? Minus 2. So we just substitute minus 2 there. And then finally it's 3 plus 2. Our common difference is just simply 5. There we go. It's our final answer. Okay, 2.1.3 now. It says, explain why none of the numbers in the arithmetic sequence are perfect squares. Okay, so first of all, we have to understand what a perfect square is. Okay, so I hope you know what a perfect square is. But in case if you don't know, that's numbers like 4 that were in your square roots, they give you a perfect number like 4, 9, 25, those sorts of numbers. So you need to think about this a little bit clearly. Okay, now that we know what a perfect square is, we know that T1 is equals to, we solved it upstairs. Okay, it's minus 2. T1 is minus 2, right? Now we know the difference is 5, so T2 is minus 2 plus 5, which gives you what? What does it give you? It gives you, it's 5 minus 2, which is 3. T3 is going to be 3 plus 5, which is 8. And so on and so on. None of these will would ever be able to give you a perfect square. Perhaps if T1 was a different number, then or a number that leads towards a perfect square number, then maybe we could have a perfect square. But because T1 is minus 2, then we can never ever ever have a perfect square. So I'll write it like this. The reason that we cannot have have a perfect square is because of T1, is because T1 is minus 2. If maybe T1 was minus 1, then we can have a perfect square, because minus 1 plus 5 would then give you 4, and 4 is a perfect square. But this whole thing has to do with T1. If T1 is a different number, then we can get a perfect square if it's minus 1. But since it's minus 2, then we can never have a perfect square. Well, I hope you understood. Okay, let's look at the next question, which is 2.2.1. It says the following sequence of numbers form a quadratic sequence. So we're dealing with quadratic now. There are the numbers. The first difference of the above sequence also form a sequence. Determine an expression for the general term of the first difference. Well, you have to understand the English here. Okay, but basically we have a sequence. The first one, this is the sequence. It's 3 minus 3 minus 2 minus 3 minus 6 and minus 11. Now, when they say the first difference, they mean we have to subtract the numbers. Say minus 2 minus 3, that gives you a positive 1. And then this one right over here, minus 3 minus 2, that should give you minus 1. Okay. And then the next one is these two numbers, minus 6 minus 3, that should give you a minus 3. And then the last one is minus 11 minus 6, it should give you minus 5. Okay, so this is the first difference, right? And then it says it forms a sequence. Now it says determine an expression for the general term of the first difference. Now we need to find the general term of this difference. First of all, what kind of sequence is this? If you say arithmetic, then you are correct. So with an arithmetic, we need to find the difference. That's term 2 minus term 1, which is minus 1, which should give you minus 2. You can check that as well by saying minus 3 minus 1, which still gives you minus 2. So the difference is minus 2. Now we know that the general term is given by Tn is equals to A plus N minus 1 D, right? We know this. Now, as we look and continue with this question, we need to substitute the values of these variables. What is A? A is 1 plus N remains, and then the difference, we solved it to be minus 2. So all we need to do now is get rid of the brackets. So we'll multiply the minus 2 times N. We have 1 minus 2 times N. We get, let me rub this plus, because we actually get a negative 2N. And then negative 2 times negative 1, we get a positive 2, such that our final answer is therefore, what is this? 3, 1 plus 2 gives us 3 minus 2n. Now this is the general term that we were looking for. So let's look at the next question. It says calculate the difference between the 35th and 36th term of the sequence. So let's just complete the question. Okay, it's complete. Calculate the first difference between the 35th and 36th term. Okay, so what I have to do then here is just simply put this in a calculator, or rather okay, let's go, no, not red, let's go purple. In understanding the question, okay, we have 2.2.2. calculate the first difference between the 35th and the, so what I'm going to do is that I'm going to take this Tn, which is 3 minus 2n, and then I'm going to substitute the 35th term. Okay, and then once I have the 35th term, I'm going to put it in the equation, which is 2 times 35. Let's see what we get. Where's a calculator? Come here, calculator. So we have 3 minus 2 times 35, and we get minus 67. That's our 35th term. Cool. Calculate the first difference between the 35th and the 36th term. Now, what I want to show you is that this term that they're talking about is remember, this is term 1, that's term 2, term 3. They're talking about the original. Okay, they're talking about the original sequence. They want the difference between the 35th and the 36th term. But now, because this general formula is for the first difference, okay, if we find, that's the answer they're looking for. So if we find the 35th term of the first difference, then we find the difference between the original 35th and 36th term. That's what we are looking for here. I hope it makes sense. Once again, the reason I used this formula and said the 30, even though I found the 35th term, remember, this is a 35th term of the first difference, not of the original quadratic sequence. You need to read the English. It says of the quadratic sequence, and the quadratic one is the first sequence. This is the quadratic one. But this formula is of the arithmetic one, which is of the first difference, and that is why we use this formula then to find that first difference number, which is minus 67. Okay. Okay, so let's look at the last question now. Okay, let's look at the last question. So it says that is 2.2. Oh, it's not the last question. Determine the expression for the nth term of the quadratic sequence. Okay, so we're talking about the quadratic sequence. This is 2.2.3. Now we are looking at the quadratic sequence. So there we go. We need to complete this so that we get the second difference. All right, so in completing this, minus 1 minus 1, I get, what do I get? I get minus 2, don't I? Minus 2. And then here, minus 3 minus minus 1, I get minus 2. And then here, minus 5 minus minus 3, I get minus 2. So we know that this is the second difference. This is the second difference. And what we do really with these ones is that we say 2a is equals to minus 2. And then for this one, we'll say 3, right? 3a plus b will equals to this one. Okay, let's take that downstairs. Okay, so if you remember what we had minus 2, okay, and that was equals to, okay, let me write it like we wrote it up there. It wasn't, I said 2a is equals to minus 2, such that a is now equals to minus 1. And then that other one, it was 3a plus b, and it was equals to 1, right? But we already have the value of a, so let's just substitute it. Plus b is equals to 1. Therefore, b is equals to, if I take this minus 3 to the other side, it becomes positive 3. So it's 1 plus positive 3, which gives us what? It gives us 4. Then the last one is just a plus b plus c, and that's going to be equals to that first number. Okay, just to complete this, so now this one is a plus b plus c is equals to minus 3. Okay, remember that a plus c plus b is equals to minus 3. So in place of a, we've already solved it. It's minus 1. B is 4. The only variable missing is C. The side it's minus 3. So C is minus 3. I take it 4 to the other side, it becomes negative minus 3 minus 4. That gives us minus 7. Minus 7 plus 1, because we take this 1 to the other side, and then we're left with minus 6. Okay, so now Tn for quadratic is a quadratic equation. Okay, so it is n, it is an squared plus bn plus c, right? Then we can substitute. We know a is minus 1, so it's just minus n squared. And then b is plus 4, so it's plus 4n. And then c is minus 6. So this is our general term for the quadratic. Okay, the real last question now, 2.2.4. Show that the sequence of numbers will never contain a positive term. Okay, so this is one of those questions, likewise, that need you to think a little bit. So if we look at the sequence, it starts from minus 3, right? And show that the sequence of numbers will never contain a positive term. It starts from minus 3, and you can see that it's kind of jumping. And also our first difference, and if you check our difference, really it comes down to minus 2, right? Our second difference, it comes down to minus 2. Now whatever you do, this, because of this minus 2 being negative, because of this number being negative, that means the sequence will never ever be positive term, ever, right? So in our reason, there we will say given that minus 2 is a negative number, let me write that. Given that the second difference is a negative number, that is negative 2. Therefore, let me just write, therefore the sequence will never contain a positive term, especially considering that it started on a negative term. At least if it had started at maybe 1 or any positive number, then it would contain a positive term. But since it started on a negative number and the second difference is also a negative number, then it will never ever have a positive term in the sequence. Well, thank you so much. Please do like and subscribe to our channel. We do appreciate it. Stand by for another loud advert. Brace yourself. Well, welcome once again. We're in question number 3 now. Let's get right into it. So 3.1, it says given the sum of that, determine the sixth term. Now this requires you to differentiate between the terms and the sum. you must know to get the sixth term, when it comes to the sums, you must take the sum of the first 6 numbers and then subtract the sum of the first 5 numbers. Then you will get the sixth term, right? So let's start with the formula, which is Sn is equals to 4n squared plus 1, and then we will do 6 first, and that's going to be 4. That means where there's an n, we put a 6. So here we have a 6 squared plus 1. Let's get a calculator real quick. Okay, so it's 4, open the bracket, put a 6, close it, square it, and then say plus 1. What do we get? We get 145, right? Now let's do the same for the first 5 numbers. That's gonna be 4, where there's an n, we put a 5, square that, plus 1. What does that give us? I'm just gonna go back here, delete that 6, I'll put a 5. That's equals to 101. Now term 6, as we've said on top here, is going to be sum of the first 6 numbers, which is 145, minus the sum of the first 5, which is 101. Put that in a calculator. What do we get? Right? So it's 145 minus 101. Cool. So T6 is just simply 44. That's it. That's just it. Thank you so much, Mr. Calculator. Let us now move on to the next question. Let's change color to black this time, and that's gonna be 3.2. For which values of x will the following series converge? Now we know that a series converges when the ratio, is between -1 and a +1, which means we must now get the value of our ratio over here. Now that requires you to do a few things. First of all, we must actually identify the variables that we are given right here. So this is T1, right? And that's T2. And then the final one is this one. That's T3, right? And then remember that R is T2 over T1, which is also T3 over T2. So we can take any of them, right? Let's, for argument's sake, let's take this one, T3. So what's T3? It's 4, it's in brackets, x minus 3 to the power 3 divided by T2. That's now 4x minus 3 to the power 2. See what's going on? So when we divide these two bad boys right here, we get that R is just simply 4x minus 3, because look at the exponents right here. You just say 3 minus 2, since the bases are exactly the same. So you just subtract them, and then you're left with that. Now we know our value of R. We go back to our condition. So which is R is between -1 and a +1, and we just substitute this such that we have 4x minus 3 is less than 1, but is greater than -1. Okay, so what happens from here? From here, then we'll take the 3 to the other sides, so that we're left with 4x is less than, so what's 1 plus 3? We get 4, right? This side, what is minus 1 plus 3? That's a 2. Okay, then we have to further simplify by dividing all sides by 4, right? Okay, so we'll divide everything by 4, and then we'll be left with x is less than 4 divided by 4 is simply 1. This side is 2 divided by 4, that's just a half. Okay, so this is now our final answer right there. That's it. Okay, now if you are interested, you can go further actually, and make a condition here and say x can never be equals to, so you cancel that. You see what that is, where x is? It can never be 3 over 4. Why 3 over 4? Because 3 over 4 will, this 4 will cancel that 4, and then you'll be left with 3. It becomes 3 minus 3, which gives you a 0, which is incorrect. Okay, so this is a condition that x is between a half and 1. 3 over 4 is between a half and 1, isn't it? Okay, but we have to exclude it because it can never you know, satisfy the conditions right there. Okay, cool. Let's move on to the next question. Now this one is a little bit more, what shall I say, interesting. Okay, so it says calculate that. Okay, this is, so we are given k is equals to 3, and then they put a 5 there, and then they put a -1, and then to the power k times 2 over k. Okay, this is what we have to evaluate. What I want you to notice is that this number k starts from 3, and then it ends at 5. The bottom one is the start, and then the top one is the end. But these numbers are the values of k that you substitute into this formula, right? So to get the first term then, the first term is going to be where k is equals to 3. So we will have -1 to the power 3 times 2 over k is 3. That's our first term. Okay? Okay. Now, because of this sigma notation, it means sum, which means we must add. Okay, so I'm going to put a plus there, and then move to the next number after 3, which is 4. Substitute it into the equation. So I'm going to have -1 to the power 4 times 2 over k is 4. And then the last one, which is the number on top, is 5. So I'm going to have -1, right? K, which is 5 this time, and then 2 over 5. Okay, now at this point, I just want to bring in the calculator, put everything in the calculator exactly as it is. So I have -1 to the power 3, and go downstairs, and then it's times 2 over 3. Okay, go to the side, put a plus there, start the process again, -1, close it, to the power 4 this time, and then I'll go to the side, times 2 over, what's this time? 4. And then I'll go to the side, plus, open the bracket, -1 again, close it, to the power 5 this time, go to the side, times 2 over 5. That's going to be equals to minus 17 over 30. Now that is your evaluation. That's the final answer. Well, if you enjoyed that, please do like and subscribe in our channel. We will greatly appreciate it. Okay, question 4, here we go. Consider the following graphs. Okay, yeah, I see G and I see H. Cool. It says this, write down the domain of G. So we can look at the domain of G. And remember, domain has to do with the X. So I'm just going to say 4.1. The domain is X is an element of all real numbers except X cannot be equals to minus 3. Okay, because remember, when it comes to these hyperbolic graphs, X plus 3, when you are looking at the asymptote, you always take the opposite sign. Okay, but when you are looking at the range, you take the sign exactly as it is. Okay, but anyway, it says here 4.2, write down the range of H. There's H. So you see it's plus 2. So we take it exactly as it is. So first of all, any value of y works, but y cannot be equals to a positive 2 because we have an asymptote right there. Okay, now let's look at the next question, which is question 4.3. If the graph of G is shifted so that it coincides with the graph of H, okay, how many units must the graph be shifted horizontally? So horizontally, we're talking about the x-axis. Now, if we look at the x-axis, which is basically like that, and we look, where are we at the graph of G, it starts at negative 3. Okay, and then the one of H is at positive 3. So we move from negative 3 to negative 2, negative 1, 0, 1, 2, 3. And then now we have to count how many units is this. It's 1, 2, 3, 4, 5, 6 units. So it's 6 units to the right. To the right. Hey, go away. Sorry, that's my son. He's a very naughty boy. See, he made me write 4.2 when it's actually 4.3. Now this was 4.3.1. Let's look at 4.3.2 now. It says how many units must the graph be shifted vertically? Okay, so vertically now we're looking at the y-axis. Okay, so what's happening on the y-axis? Now, if we look at the y-axis here, it moves from G is negative 3 over 2, which is like 1.5. So it's negative 1.5, right? And then we move to, let's say, negative 1. We're going all the way up until we reach 2, right? Negative 1, and then we'll have 0, and then we'll have 1, and then we will reach finally 2. So how many units was this? This is a half unit, and then this is 1.5, 2.5, and then 3.5. So this is 3.5 units up. That's it. Okay, let's look at 4.4 now, and it says write down the equations of the asymptotes of G. Okay, so we looking at G. Remember, this one is G right there. Okay, sorry, that one is G. Oh, okay, doesn't want to highlight this time. Oh, I'm supposed to choose a color. Okay, let's do that. This one is G, right? This one, that's G. Cool. Looking at the asymptotes, we get them there. Let's start with the x1. We've spoken about it. X is equals to the first asymptote, opposite sign, -3. On the y, we take it exactly as it is, which is -3/2. Okay, and then it says calculate the x-intercepts. Okay, let's calculate the x-intercepts as they want. This is now 4.5. Calculating the x-intercepts, we always let y equals 0. So let's just write the equation first. X plus 3 minus 3/2. And what you want to do is to say let y equals 0, so that we have 0 here is equals to 6/x plus 3 minus 3/2. All we have to do now is some gymnastics, mathematical gymnastics. So we'll first of all multiply everything by x plus 3. So this side is still going to be 0. This side is going to be 6 minus 3/2 times x plus 3. Then I want to multiply everything by 2. This side is still going to be 0. And then 2 times 6, that's 12, minus 3x plus 3. Now I want to get rid of the brackets by multiplying in, like that. The side is still 0. I got 12 here. Minus 3 times x is minus 3x. Minus 3 times 3 is minus 9. Okay, now I want to take numbers on one side and leave, or maybe let me take this 3x this side. It's gonna be just 3x is equals to, what's 12 minus 9? That is 3. And then x divided by 3 for x is equals to 1. That's our final answer right there. Nothing more, nothing less. If you want to write it in coordinate form, yes, you can, because the coordinate will be 1 and the value of y is 0, just like that. Well, let's move on to the next question, which is sketch the graph of G. Right, so this is now 4.6. Before we sketch it, we need the y-axis, the y-intercept as well. So we're just going to say let x equals 0. We go back to the equation. It's y is equals to 6/x plus 3 minus 3/2. This time we said let x equals 0, so it's 0 plus 3 minus 3/2, and then we get 6/3 minus 3/2. Let me get a calculator for this one. just so that I don't waste time. 6 divided by 3 minus 3 divided by 2. Cool. So that's a half. Y is a half. And if I want to write it in coordinate form, this will be, remember we said x is 0 and a half. I can now draw, essentially I can draw my graph. Cool. So let's do that. I have everything I need. Okay, first of all, we would like to start with the asymptotes. Okay, so that's my Cartesian plane right there. Okay, and for my asymptotes, I have one at -3, okay, on the x. So I'm just gonna say -3 here, and then we complete the asymptotes just like that. Okay, at -3, and then the other one is minus 3/2, which is like 1.5. Cool. So I'm gonna do it right there. So this is gonna be -3/2, and then just to complete it like that. So always start with asymptotes, and then for my intercepts now. I have one intercept. Let me just complete the intercept. I have one intercept at a half right there. So positive a half. That's the y-intercept. And then the x-intercept, I have it at 1. We solved it up there at the position 1. All that's left is for me to draw the graph. Now, that means my graph is passing these 2 points. And remember how these graphs go. They go towards the asymptote. That's not going to work out. Let's try the drawing again. It must pass these 2 points like that to go towards the asymptotes, but not really touch them like that. And then this one is just going to be like that as well. Goes towards asymptotes, but not touch them. Okay, well, I know it's not so accurate, but you get the full points for drawing it like this and crossing the what you might call the intercepts, and you draw them on this quadrant because this is a positive in hyperbole. Okay, that's cool. It said clearly show all asymptotes and intercepts. Okay, so we have done that. Cool. Let's go to the next question. This was question what, 4.6. All right, let's go to 4.7 now. Now 4.7 says determine the value of k if h is that is an axis of symmetry of G. Okay, so we have just drawn G, the graph of G, right? So now we just need to determine where is the axis of symmetry, right? So the axis of symmetry is right there. This is the one with a if you look here, you can see that it has a negative, right? It has a negative, this thing doesn't want to highlight. It has a negative gradient, which means it passes this point of intersection, right? And it's this graph that we are looking for. Now, the point that it passes is the point of intersection, which is -3 and -3/2, the coordinate of it. So what we are going to do then is that we are actually going to solve it. We're going to say y is equals to, now this is for 4.7, y is equals to minus x plus k. And we're going to substitute minus 3 and minus 3 over 2. This will represent the x, that will be the y. So in place of the y, we'll put minus 3 over 2, that's equals to minus. In place of the x, we'll just put minus 3, and then we can solve for k using some gymnastics. So this is going to be positive all in all. I'm sure you can see that. So I'm finally going to have minus 3 over 2. If I take this to the other side, it becomes minus 3, and all of that is going to be equals to k. I don't want to waste time, so I'm just going to put it in the calculator. It's minus 3 over 2, and then you go to the side, we say minus 3. What do we get? Minus 9 over 2. Therefore, k is equals to minus 9 over 2. There we go. Right there. Just like that. Well, that completes that question. Now let's move on to the next one, which is 4.8. For which values of x will the graph of g be greater than the gradient? Okay, let's come and look at that here. Now, if we are coming from infinity and going that way, right? So what's happening here? We can see that this is the graph of this is the that graph minus x, the symmetry of g, this one, and then this is the graph of g. So if we're coming from negative infinity, we can see that right now the symmetry line is greater than the graph, okay? But from this point of intersection, now we can see that after minus 3, okay, after this asymptote of minus 3, we can clearly see that the graph is now on top, which is greater than the line. Okay, so our answer then will be any value that is greater than minus 3. We will always have this condition where the graph is greater. By greater, visually, it means it's on top, it's above, it's greater, it's above. Okay, so then our answer then for what color am I gonna go with? Let's go with dark gray. So 4.8, our answer for this condition, the values of x is values of x that are greater than minus 3, just like that. Okay, let's now look at the final question, which is 4.9, and it says the graph of g is reflected in the x-axis. Write down the equation in the form y. Okay, so a few things that we have to know. The equation, the normal equation, is 6 over x plus 3 minus 3 over 2. Now, I want you to look at me. Okay, look at this. If we put a mirror on the x-axis to mirror this graph, or any graph, or yeah, let's just say this graph, you can see the value, the value of the x doesn't change, but the values of the y change. Okay, which means if it was positive, it becomes negative. If it was negative, it becomes positive. Right, so how that translates then for our graph is that, all right, because we want the y to remain positive, what we're going to do is put a bracket on everything here, okay, and multiply it by -1. Okay, what does that do? That's the condition for reflecting by the x-axis. So what that leaves us with is that we're gonna have -6 over x plus 3. Okay, the minus only affects the top of the fraction. I hope you still remember your fraction rules. Okay, and then when it comes, because remember we're multiplying this there, and then the last one we're multiplying this, the minus there. What that does is that it changes then that to become a positive 3 over 2, and then that's your final, okay, answer. Well, I hope you understood everything I was trying to explain. I've heard this helps us with our algorithm on YouTube, so please like and subscribe to our channel. It will really, really help us. Other than that, let me catch you on the next question, question 5.
Right, now we're going to have a look at question 5, our functions. All right, so we have the graph of f of x, which is a sad face parabola, and g of x, which is a straight line that has a negative gradient. Okay, and those are sketched below. The graphs of f and g intersect at points D and B. Okay, so at points D and B, that's where the two functions have the same x and y coordinates. And points A and B are the x-intercepts of f. And I hope that you see that the way f of x has been written out, it's actually in the form where you can actually see the turning point. So you can see the x coordinate as well as the y coordinate of the quadratic function. So let's go ahead and answer the questions. So it says write down the coordinates of E, the turning point of f. All right, so that's just straightforward. You're gonna read that off. So we have 7 over 2 and 81 over 4. Okay, that was just straightforward. And 5.2 says determine the average gradient of the curves of f between x is equal to 1 and x is equal to 5. All right, so it's probably what? Somewhere around. Okay. I don't know where 1 is. I mean, if I knew what b was, but let's just say it's a gradient around there. Okay. So because we have a curve, and if we want a gradient between certain points, it will have to be the average. Because with the curve, there are gradients literally everywhere on the curve. So if we're going to get the average gradient, it'll be the y value for f, where x is 5, minus the y value where x is 1, all over 5 minus 1. And we're just going to take our calculators and substitute the value of 5 where we have x. So negative 5 minus 7 over 2 squared plus 81 over 4. Okay, and we get a value of 18. And now if we substitute 1, we get 14. So 18 minus 14 over 4. And that's basically 4 over 4. So the average gradient is 1. Okay, not so bad. Now let's go to 5.3. And it says calculate the value of A, the x-coordinate of point D. So as we said before, D is an intersection between F and G. So basically that is where your graph of F is equal to your graph of G. And we need the x-coordinate there. So we're basically going to solve for x. So we have our equation for F and our equation for G. Let us just simplify F for a moment. Okay, so if I were to multiply out this bracket, I have a negative there, so I would have x squared, and then minus 7 over 2 minus 7 over 2, that should be minus 7, okay, because 7 over 2 is 3.5, so 3.5 minus 3.5 minus 3.5 is minus 7, and then we have plus 49 over 4, and then we have 81 over 4, and this side we just have the negative 3x plus 24. So if we put in the negative, we have negative x squared plus 7x plus 49 over 4. I'm just going to put it there. Sorry, negative 49 over 4. Because we're multiplying in the negative. So we have negative 49 over 4. Let me just put it under its own bracket. And then plus 81 over 4. We need to just simplify that because it is not nice working with fractions. So if I were to have negative 49 over 4 plus 81 over 4, okay, I get 8, which is nice. No more fractions. So negative x squared plus 7x plus 8 is equal to negative 3x plus 24. So I'm going to take everything to the right side. Okay, now I have x squared minus 7x minus 3x plus 24 minus 8. Okay, this is getting a little bit better. So now I have x squared minus 10x and 24 minus 8. Sorry about that. That should be, what, 16? Yeah. So plus 16. Okay, and we know the factors of 16 that can give us 10 would be 2 and 8, right? So there we go. If you don't really know how to factorize using two brackets, please just go straight to the quadratic formula. It'll take a bit long, but at least you are confident that you have the right answer. Okay, so we have 2 and 8, and we just pretty much do that. Therefore, x is equal to 2 or x is equal to 8. But where does D lie? Because one would be the coordinate, x coordinate of D, and the other would be the x coordinate of B. Okay, so we can see then that the x coordinate of D, okay, so x, D is actually going to be 2, all right, whereas this one would be xb. All right, and how many marks was that? 3 marks. If you're quicker with working out these things, then yeah, it works out. But if you need to take it step by step, so be it. Now 5.4. It says point S is a point on the graph of F. Okay, we can see it. It's right over there. Where X is in between A and 8. Okay, remember A is 2, so it's in between 2 and 8. Yes, it is. And line ST is drawn parallel to the y-axis with point T on the graph of G. Determine ST in terms of X. Now, what is ST? ST, so S for 1, all right, would be a point on F, okay? And T is a point on G. And the vertical distance in between them, it's like taking the y-coordinate of S minus the y-coordinate of T, okay? And that would give you the length ST because they are pretty much parallel to the y-axis, okay? So basically what I'm saying is S, the y-coordinate, or rather, we could have just said we have f of x, okay? The y-coordinate there, which is S. And then for t, that is where we have g of x. Okay, so t is at g. I hope I'm making sense. So yeah, basically you're going to take the equation of f, all right, and subtract the equation of g, and then you're going to get the length of st. So let us do that. So we have negative x minus 7 over 2 squared plus 81 over 4. That's just f. And we're going to subtract negative 3x plus 24. And that would be equal to st. And they wanted st in terms of x. Okay, because we really don't know what the x value is there. But maybe we might later on. I don't know. But yeah, let's just multiply that out. And we did already in the previous question. So we don't need to do the whole thing again. We can just say negative x squared plus 7x plus 8. And then just multiply in the negative. So we have plus 3x minus 24. And that's equal to st. So if we simplify, we're going to get negative x squared plus 10x and minus 16. And that is equal to st. So that's st in terms of x. And how many marks was that? 2 marks. All right, anyway, so 5.5, the last question. Calculate the maximum length of ST. So whenever you see maximum or minimum, think about calculus. Think about getting the gradient, okay, or the first derivative and making it equal to 0. Okay. So don't think, we're dealing with functions here. The calculus questions are probably there by question 7. No, this is maths. You can apply anything, anywhere, anytime. They could even ask this in paper 2. Okay, so just be ready. So basically we have a function. So for st, we know that st is equal to negative x squared plus 10x minus 16. So basically we're trying to get the first derivative. So dst over dx, okay? Derivative in terms of x. And we know that using the power rule, we're going to bring down the power. So you have negative 2x, and we're going to subtract 1. Okay, so to the power 1. But we hardly ever write that power 1, but that was just to illustrate. And then, again, we have a 1 there, take it down, plus 10, subtract 1, anything to the power 0 becomes 1. All right, and any number there by itself, really the derivative is just 0, so we're not gonna write anything there. So we have negative 2x plus 10 is equal to 0. Now if we solve for x, we will get that 2x is equal to 10, so x is 5. Okay, and now are we there yet? Not yet. They wanted the maximum length of st. So st we know that it is negative x squared. So we're going to have negative 5 squared plus 10 times 5 minus 16. And you can just put all of that in the calculator just to save time. And what do we have? So we have negative 25 plus 50 minus 16. And our answer is 9. So ST is 9 units. Okay, and that sums up question 5. Question 6. I see we have been given an exponential function. So the graph of f of x is equal to 3 to the power x is sketched below, and we're also given a point P. All right, which is there. Now they're asking for 6.1. Write the inverse of f in the form y is equal to blah, blah, blah. So initially we have y is equal to 3 to the power x. And whenever we write the inverse, we need to swap the x and the y. And then write this in terms of y. So y in this case would be equal to log base 3 x. Okay, for those of you who don't really understand how we got there, so basically, if you have x is equal to 3 to the power y, if you put log on both sides, according to the log rules, you can take down the power. So you have y log 3, and you have the log x. Then you can make y the subject of your formula. So you have log x divided by log 3. And as such, finally you can say log base 3, as it is at the bottom, x. Right, and that should probably be 1 mark. Yeah. Now 6.2, it says sketch the graphs of y, the inverse of y, as well as the inverse, which is shifted 2 units to the right on the same set of axes in your answer book. Okay, so let us do it like this. Let's just make a screenshot of it. And okay, it's deciding to misbehave now. So let's just shift it a bit lower. Okay, let us just sketch. So if we're going to look for the inverse of f, first of all, remember that your inverse is actually symmetric about the line y is equal to x. So let's just say, for argument's sake, that this is my line, y is equal to x. And then I can start sketching. So I know that my y-intercept, which is q, because we don't have any horizontal or vertical shift in the original function, for an exponential function, your y-intercept will always be at 1, because anything to the power 0 gives us 1. All right, so then I know with my inverse, the coordinates have to swap around. So I will have 1 and 0. Okay, so if I sketch my graph, which probably will not be to scale, so please bear with me, it would look something like this. All right, where I know that the y-axis is actually my asymptote. And in the original function, the x-axis is the asymptote. Okay, so this is the inverse, which is f minus 1. Now, if I want to sketch the graph of the inverse of f shifted 2 units to the right, so if I have 1 over there, then I'm going to go 2 units to the right, so I'm at 3. Okay, and therefore my graph would have shifted. Something like that. But anyway, let me do it myself. Let me sketch it again. Yeah, I can probably cut and paste, but let's just leave it there and draw it again. So it would probably be something like that. So before, if the y-axis was my asymptote, now 2 would be my asymptote for this new function that has been shifted 2 units to the right. Okay, you don't have to put the asymptote. This is just for information purposes. All right, so now this is the inverse where x has been shifted 2 units to the right. So there you would have your 4 marks. Now the last question, 6.3. It says use the graphs drawn in 6.2 to solve for x if the inverse, okay, so log 3 x minus 2 is smaller than 1. Okay, so remember our inverse here, the function there is log 3x. Okay, so our inverse where x has been shifted 2 units to the right would be the log 3x minus 2. Okay, so basically this function where it is smaller than 1. So if you have 1 over there, and you want to know where is it smaller than 1, where are the x values. So the x values would start somewhere just after 2 because it can't be at the asymptote. And where would they end? Okay, if we extended this function further, it's just we don't have space. They would end somewhere after 3. Okay, so this is where our graph or the region is applicable. But yeah, so firstly I can see that 2 is one of the answers because this function will never cross 2. Okay, it will never cross x is equal to 2. So I have 2 and I do not include it. But where does it stop? What is this value over there? Okay, I know they said you must use graphs, but in this case, I would be tempted to just use the formula itself. Okay, and what do I mean by that? I would say, okay, I have log base 3 x minus 2. Where is it smaller than 1? Okay, and I would then say, okay, I know that I have log x minus 2 divided by log 3 smaller than 1, and then I will take the log 3 to the other side. So I have log x minus 2 smaller than log 3, and if I have logs on both sides, I can basically just remove them. Okay, so they divide, so I have x minus 2 smaller than 3, and if I take 2 to the other side, I can see that my limit there would be 5. So basically my answer then would be the x values would have to be in between 2 and 5. And that is it for question 6. Very short and sweet. Question 7. A survey conducted in December 2015 determined that 5.7 million South Africans were living with HIV. The researchers used a model of exponential growth to predict that there will be 6 million people living with HIV in December 2022. Okay. Calculate as a percentage the annual rate of increase that the researchers used for the 7 years. So in 2015 is 5.7, 2022 is 6 million. You would think that with the awareness of HIV that maybe the number would decrease, but I guess, yeah, it will just keep spreading. So now using this function, this equation over here, we are, remember A, which is our accumulated amount, means by the time it's 2022, we have 6 million, right? I'm just going to say 6M. And initially, all right, we had what, 5.7 million. And we want to see as a percentage the annual rate of increase for 7 years. So for N, we have 7 years. So let's put down our equation. A is equal to P, 1 plus I. This is an exponential increase. And we're going to put in the place of A, the 6 million. So million is like 6 zeros, so you can say 6 times 10 to the power 6. And P, we have 5.7 times 10 to the power 6. And we are looking for our interest. Okay, the rate, actually, annual rate. And then we have it over 7 years. So now it's a matter of just doing some algebra. So 6 times 10 to the power 6 divided by 5.7 times 10 to the power 6. And we're going to root 7 on both sides to get rid of it on the right hand side. And what do we get on the left hand side? So let's just employ our calculator. Gonna put 7 over there. Actually, the 10 to the power 6 cancels out, so we can really have 6 divided by 5.7. And that is equal to 1,00735. And then all of this cancels, so we're left with 1 plus interest. So I is equal to 1,00735 minus 1. So if we subtract 1, we get 0,00735. And because they wanted it as a percentage, we're going to have to multiply all of this by 100. And we can see that our annual rate of increase is 0.74% if you round it off to 2 decimal places. Okay, now 7.2. And it says Shimi invests 4 million into an account earning interest of 6% per annum, compounded monthly. All right, so there we have 4 million earning an interest of 6% per annum, compounded monthly. She withdraws 30,000 Rand per month. Her first withdrawal is exactly 1 month after she deposited the 4 million. Now, how many withdrawals of 30,000 will Shimi be able to make? So in this case, if she has invested 4 million and she withdraws 30,000 per month, this is like money she has now. Okay, so we will have to use the present value formula. And if you have forgotten what that equation looks like, there it is, P. Okay, I like saying PV, so present value. So we have X, 1 minus 1 plus the interest, negative N, and all of that is divided by I. Now let's go back and see the values again. So in the place of X, I want to start with the present value. The present value that we have is 4 million. Okay, and the value of X, because it's per month there, that's the 30,000 Rand. And then the interest rate would be 6% per annum compounded monthly. And if they're asking for the amount of withdrawals, we're basically looking for N. Okay, so that's something we just put on the side. And let's just fill in all the information. So we have 4 million. Don't forget any zero or else everything will be incorrect. And then we have 30,000. Let's make that a square bracket. One minus 1 plus the interest rate, which is 6%, divided by 12. And remember, we are looking for N. And divided by the interest rate. Okay, so this is where things get a little bit complicated, but let's just write this in a way that makes sense. So I'm going to take the 6% over 12 and multiply it by the 4 million. Okay, let's just write it out. So multiply it by 6%, or you could say 0.06, whatever floats your boat. And then we're going to divide by the 30,000. And then we're going to subtract this 1. Okay, so we have left over a negative 1 plus 6% over 12 to the power negative N. So I think at this point we can just put all of these values in the calculator. We're probably going to have to store some of these results, but let's see. So we have 4 million, 1, 2, 3, 1, 2, 3. And we have 6%. I prefer putting the percentage as is. I think you were taught to divide it by 100. So do whatever works best for you. And then we have 30,000. And we are subtracting 1. Okay, so the number has worked out quite nicely. I thought we're going to have a lot of decimals. And on the other side of the equation, we have 1 plus the 6% divided by 12. I'm going to leave it as 201 over 200 because I don't want to lose any other decimals if I... Okay, this would have worked too, but it's fine. Let's leave it as a fraction. And then I can see that I can scratch out the negatives on both sides. Now we have an unknown in the power. What do we do when we have an unknown in the power? We're going to use logs, yes. So negative n would be equal to log. This is our base, 201 over 200. And we have a third there. Okay, just, yeah, maybe it would help if you put it in brackets. I don't know, it's really up to you. But let's go to a calculator and see what that log is. So we have a log 201. That's a nice thing about a Casio calculator. You can just put things as they are. There we go. So we have negative n is equal to negative 220.27. All right, so because we are dealing with n, okay, they say how many withdrawals. At this point, you would have to round off, okay? So, because you can't say it would be 220.27 withdrawals. So what does that 27 mean? So I'll just round it off to 220 withdrawals if I'm just gonna withdrawals, unless if they say you should round up. If they say round up, then it would be 221. But because our decimal, I mean, it's 27, it's closer to 220 than it is to 221. So hence I'm choosing 220. Unless if they say otherwise. Okay, so that's 7.2.1. Now 7.2.2, it says how many withdrawals will Shimi be able to make if she changes the amount withdrawn per month to 20,000 and substantiate your answer. So we're going to do the very same thing, but now instead of 30,000, we're going to have 20,000. Okay, so we have our present value formula. And then we have 1 1 minus 1 plus the interest rate to the power negative n, and all of that is divided by the interest. Okay, so we have our 4 million. 1, 2, 3. And now we have 20,000. 1 minus, actually I think I can put what that value is. It was 201 over 200 negative n. I mean, if you've solved it before, there's no need to rewrite it again from scratch. So 201 over 2, no. This is 6% over 12. Okay, 6% over 12. Let's just make sure. Yeah. So now if I take this over to the other side, actually it is similar. I will get a third. And I have a third. And then on the other end, I have 201 over 200. No, it will not be a third because now we are dividing by 20,000. Okay, let's not copy everything. So we're going to say 4 million. Okay, so we have 4 million multiplied by 6% over 12 divided by 20,000. Okay, so yeah, let's not try to cheat the system there. So we have 1, 2, 3, 1, 2, 3 multiplied by 6% over 12 divided by 20,000 this time instead of 30, and we have 10. Remember previously we had a third. Let's see, a way of checking. Okay, what did we do there? Let me just see. Yeah. Oh gosh. Added an extra 0. I knew something was suspicious. Okay, and then we subtracted by 1. That's how we got a negative a third. Okay, now let's go back. The only difference now is that we have 20,000. So now we have 0. Okay, remember all of this is subtracted by 1. Okay, now we have 0 on the other side, which changes things. Okay, if we have 0 there, and we have 201 over 200, and we try to use logs, negative n is equal to log our base, 201 over 200, and then we have 0. What would that give us? What do you think? We're probably going to get a math error, which is saying that the answer that we have is undefined. Okay, if the answer that we have is undefined, it means that we have an infinite amount of withdrawals. Okay, which doesn't really make sense. It doesn't mean that she can withdraw 20,000 until, but that's exactly what it is. So basically she can make an infinite number of withdrawals. Isn't that amazing? So why are we not doing it if it's possible? Yeah. So yeah, basically because her interest earned equals her withdrawal amount, she'll only be withdrawing the interest amount. So that is a quite great position to be in, no matter what well, provided the interest remains the same. So I guess if the interest changes, then there will come a point where there's a limit. But if the interest remains the same, she will always be withdrawing the interest. Okay, so I think they say substantiate your answer. But basically, she will only be withdrawing the interest. Okay, yeah, she'll only be withdrawing the interest. So as long as it remains at 6%, she is in a great position. Okay, and that's where we want ourselves to be in, where you can just withdraw an amount until. Okay, now let's go to 7.3, the last question. Okay, so Estrid opened a savings account with a single deposit of 1,000 Rand on the 1st of April 2022. She then makes 18 monthly deposits of 700 Rand at the end of every month. Her first payment is made on the 30th of April 2022 and her last payment on the 30th of September 2023. So we need to see then how many payments that was. The amount or the account earns interest at 15% per annum compounded monthly. So determine the amount that should be in her savings account immediately after her last deposit is made on the 30th of September 2023. So if we were to draw a number line, I think that is what would best represent what we are dealing with here. So initially, she put in 1,000 Rand. Okay, that is the 1st of April. And then she makes 18 monthly deposits at the end of every month. So if this is the 1st of April, on the 30th of April 2022, 20. Okay, so 2022. And at the end of the month, so it's going to be 30 April, 30 May, 30 June, July, August, etc. until we get to 30 September 2023. And those amounts are done over, or rather, they are 18 monthly deposits. You can go and calculate because from 30 April 2022 to 30 April 2023, that is 13 payments. And then you have 5 months remaining. So 13 plus 5, that's 18. Okay, so 18 monthly deposits of 700 Rand. That is what she keeps putting. All right. And now let's talk about the interest. So we have 15% per annum compounded monthly. We have our N, which is 18. And let's see what amount should be in her savings account immediately after her last deposit. Before we deal with the monthly 700s, let's talk about this 1,000. So she put in this 1,000 and it is basically growing interest every month. Okay, so we're going to have to deal with that lump sum first. Then we're going to use the future value formula because she is investing now to get the money sometime in the future. Okay, so we're going to use our future value annuity formula to deal with these 700 Rands. The 1,000 is not done on a recurring basis, so therefore we're just going to use the normal compound formula because it is just a lump sum. So that is where we're going to start. But the 700s, they are done on a regular basis every month. So we're going to have to employ the annuity formula, future value annuity formula. So our principal amount is 1,000. 1 plus the interest rate, which is 15%, divided by 12 to the power n. That is also going to be over 18 months. Okay. And let us then find out what that amount is equal to. Okay, calculator. Okay, so we have 1,000, 1 plus 15% divided by 12 to the power 18. So that amount is 1,250. I would suggest that you save it. 1,250,58 cents. So shift store. I'm going to put that as A. All right, now let's get to the annuity portion. So we've dealt with the 1,000, which will be applicable for the 18 months. Now let's deal with the 700s, okay, that are coming afterwards, which is a future value annuity. Let's go have a look at the formula for the future value annuity. There it is. Okay. So, future value annuity monthly payments, which would be the 700. Interest we already have. Our N we have. So basically have everything we're looking for, that future value. All right, let's go back to the question. All right, so we have 700 in the place of X. 1 plus the interest rate, which is 15% per annum compounded monthly. And that is done over 18 payments for 18 months. And that's just divided by the interest rate. So 15% over 12, or 0.15 over 12 if you prefer. And we see then, so 700 multiplied by 1 plus 15% over 12 to the power 18 minus 1, close the brackets, and we have 15% divided by 12. And we get an amount of 14,032 rands and 33 cents. Okay, so at the end, the amount that should be in her savings account after her last deposit would be, so let's just say the amount would be the, I think 1,250 we had initially. 1,250, comma 58 plus the 14,032. So I'm going to then take my answer and I'm going to add it to my saved value over there. And the total then is 15,282. Just write that out nicely. Yeah. Start again, 15,282 rands and 91 cents. Okay, and that is it. We are done with question 7. This paper doesn't look like it was that bad. So yeah, out of 15. All right. Thank you.
Well, let's look at question number 8. Okay, so 8.1. It says determine, oh, that's the first derivative from first principle. That's very important. It has to be from first principle. Okay, so what we are going to do here is that we are going to take and separate. Let me just rewrite the first principle first. That's f of actually let me just write the function itself. 3x squared minus 6. Now, do they give you the first principle on the formula sheet? Let me see. Doesn't look. Oh, there it is. Yes, there it is. That's the formula right there. So what we're going to do then here is that we are just going to take this part. We want just this part of it, fx, so that we do it plus h, so that we do it step by step. What does this mean? It means where I have x, I substitute x plus h this time. Okay, so it's gonna be 3 and then x plus h right over there squared minus 6. Okay, now what I like to do is actually open two of these brackets to avoid mistakes, but I'm just, because it's simpler this time, I'm just gonna go straight. Now I know that this will give me x squared, and then it's 2 times the first term times the second term, which will give me 2xh. Do you see that? And then the last one is just h squared, right? Okay, now that's all minus 6. Now what I want to do is multiply the 3 in like that, so that's gonna give me 3x squared, multiply it right over there, plus 3 times 2, that's 6xh, and the last one will be plus 3h squared minus 6. Okay, so that completes this part of it. Now I can go back now to the equation of the derivative, which is f1 of x. I just want to rewrite it first. Okay, that's the limit as h turns to 0. And then the function is x plus h, right, minus f of x whole divided by h. Cool. So all I want to do now is substitute, because unfortunately we always have to rewrite this. Substitute fx plus h, which is this thing that we wrote here on top. I'll substitute it exactly as it is. It's 3x squared plus 6x h plus 3h squared minus 6. Now this part of it minus fx, I'm gonna put it in brackets first, minus fx, that's the original function, which is 3x squared minus 6. Cool. So all of this is now divided by h, right? Fortunately, we have to keep writing this limit as h turns to 0. 3x squared doesn't, let me tick it, is going to be subtracted by this one. Okay, so it's not going to be there. 6xh, there's no other term like it, so I will write it down. Okay, Now, plus 3h squared, is there any other term like it? There's none, so I will write it down. Now this one, the number minus 6, remember when I multiply this one and that one, it becomes positive. So it's like minus 6 plus 6, which will basically just give me a 0. So I do not write it. I divide by h. Cool. So what I want to do now is that I want to factorize this. I look at the common factor, which is h. So I take h out, and then I'm left with 6x plus 3h, right? And then divided by h. Okay, so from there, I have the limit as h turns to 0. And now these h's cancel each other, right? And then I'm left with, what am I left with? 6x plus 3h. At this point, I now want to substitute 0 where there is an h, and then I will have 6x plus 3 times 0. So my final answer is 6x. That is my derivative. Okay, let's look at the next question, which is 8.2. Determine the derivative of f of x. So f of x is given by, open the bracket, it's 2 square root of x minus 1 over x squared. Okay, so what I'd like to do is just simplify this, and I'm going to do that first by opening two brackets. I'm going to have 2 square root of x minus 1 over x times 2 square root of x minus 1 over x. Okay, that's what that square means. And then from there, I'm going to multiply it out. The first one is this one. It's 2 times 2, which is 4. Square root of x times the square root of x is just x. The next one, I multiply this 2. 2 times 1 is just 2, right? And then the square root of x goes on top, right, over x. And then the next one I'm multiplying is these two. I'll get the same thing. 2 square root of x over x. Do you see that? And then the last one is these two multiply. First of all, they give me a positive answer, and it's going to be 1 over x squared. Okay, let me further simplify this. This one just stays as 4x minus, okay, minus 2 minus 2. That gives me minus 4. And then the square root of x right there, because it's the same term, everything else will remain the same. So this is a square root, but hold on, let me actually remove the square root, and let me write the square root as an exponent. This is x a half, okay, over just x. Cool. All right, and then the next one is gonna be plus, I want to rewrite this. Okay, let me just leave it as it is for now. Let me leave it as 1 over x squared. Now I want to bring the x's on top so that there are no fractions. Minus 4. What does this give me? It's a half minus 1. This is 1. So what's a half minus 1? If you said to me it's minus a half, then you are right. It's to the power minus a half. Oh, x. Let's write x first. It's the x first. Okay. So it's x a half minus 1, which gives you minus half, like that. And then plus this one is just x minus 2. Remember, if you bring it on top, it becomes minus, just like we did for this one. Now, this is f of x. We just simplified it. It's not the derivative yet, but we are now ready to solve the derivative. So the derivative, therefore, is going to be equals to 4, because it's 1 times 4, which is 4. Then 1 minus 1 is 0. So that 4 remains on its own. This side, it's minus a half times minus 4, which gives us a positive 2. Okay. And then it's minus a half minus 1, which is minus 3 over 2. This one, it's minus 2 times 1, which gives you minus 2. And then x, and then it's minus 2 minus 1, which gives you minus 3. And that is our final answer. Well, if you wanted to continue and make it fractions, you can say 4 plus 2, and instead of this minus, remember what a minus does, it takes it to the bottom so that it's positive. And because it's divided by 2, it means we have a square root, but we have a 3 there, so the 3 goes there. Minus 2, right? Remember, the minus takes it to the bottom. It's not divided by a half, so there's no square root. So it's just to the power 3, like that. You can also leave your answer just like that. Okay, let's look at the last question, 8.3. Given this function, which is, as you can see it's a cubic function, determine the interval for which f is concave up. Now this requires you to know a certain theorem. To know concave up or concave down, we need to go into the second derivative. For concave up, okay, the second derivative of x, of the function, must be greater than 0 or positive. That's for concave up. That's the condition that we are working towards. That's the vision. So let's get down into business. First of all, the function f of x is equals to 3x cubed minus 3x squared plus 6x minus 2. Okay, and then f1 of x, the first derivative, 3 times 3 is 9, x, 3 minus 1 is 2, 2 times negative 3 is negative 6, x, 2 times 1 is just 1, plus 1 times 6 is 6, 1 minus 1 is 0, so, and then there's no derivative for a constant or number. The next one is the second derivative now. 2 times 9 is 18, x, 2 minus 1 is just 1. There, 1 times 6 is 6, 1 minus 1 is 0, and there is no derivative for a number. Cool. Now we are ready. We have f of x, just like in our condition. So let's just put it in. It's 18x minus 6 must be greater than 0. Okay, so now what we're going to do is take that 6 to the other side so that we have 18x is greater than 6 because it changes sign, and then we divide both by 18. Now we know that 6 divided by 18, we can simplify it such that 6 goes into 6 once, 6 goes into 18 3 times. So that is our final answer. Well, thank you so much for tuning in thus far. Please do continue to support us by liking and subscribing to our channel if you haven't already done so. It helps with the algorithm to push this this memo to other students who might need it. Well, other than that, I appreciate you, and let me see you on the next question. Well, we are now on question number 9. Okay, let us get right into it. So, sketch below is the graph of the first derivative. The derivative of this cubic function right there. Points A, B, and C are the intercepts of the derivative with the axes. So I can see it A, B, and C. I think that's a -2 there. That's a 1. I don't know. Oh, it wasn't given. Okay, so the first question is write down the value of A. So as you can see, A is just the what we call the y-axis, and to solve the y-axis we always say let x equals 0. But before that, remember the original function, okay, f of x is equals to minus 2x cubed minus 3x squared plus 12x plus 20 as given below, above right here. Now, what is sketched here is the first derivative, and that is what we need to determine. Okay, so 3 times 2 is minus 6x, 3 minus 1 is 2. Okay, again, 3 times 2 is minus 6x, 2 minus 1 is just 1, and then this one, 1 times 12 is just 12, 1 minus 1 is 0. Again, there's no derivative of a number. Right, so now we have this. Now that we have that, we can then say, because we're looking for A, the y-intercept, which is, say, let x equals 0. So that y now is going to be equals to minus 6 times 0 squared minus 6 times 0 plus 12. Therefore, y is equals to 12. The coordinate form A is therefore equals to 0 and 12. That's it. And then it says determine the coordinate of B and C. Okay, so once again, we do know that 9.1.2, that's this function, okay, is equals to y is equals to minus 6x squared minus 6x plus 12. Okay, that's the function. Now to determine the x-axis, the x-intercepts, you say let y equals to 0. Now with this y, we substitute 0 is equals to minus 6x squared minus 6x plus 12. Now I'm going to divide everything by minus 6 just to get rid of that minus 6. And then I'm left with 0 is equals to x squared minus x plus, no, it's going to be negative 2 this time, right? Minus 2, but this one, minus and a minus, is going to be a positive, right? Let's move on. Oops, let me just wrap that. Okay, right over here, 0, we can always factorize this. Open 2 brackets. Factors of 2 is just 2 and 1. Okay, x and x. Which one is the positive one? It has to be the bigger number. The bigger number is 2. So there we go. Okay, and then I can then say the values of x is equals to minus 2, right? Or x is equals to positive 1. So I can see now that b is the one on the left. The coordinate of b is therefore minus 2 and 0. And then the coordinate of c is the one that is 1 and 0. Okay, there we go. Easy does it. Okay, and then the next question says, if I can just scroll up here, it says, okay, so we are now going to the question 9.1.3, which says, which point on the graph of f, okay, so remember a graph of f, that's the original graph, the cubic graph, will have the exact same x values as b and c. Okay, so now in order to know that answer, this is 9.1.3, you must know a bit of theory, okay, about the relationship between a cubic graph and a quadratic. So when you have your quadratic like that, this means that, okay, I'm just gonna put there, you have turning point, there is your x, and then there is your other x. So what this means is that over here where you have an x, the relationship between this graph and the cubic one is that here you will have the, let me just put in a different color, you will have the graph having a turning point right there, okay, and then it's gonna go on like that, and then have another turning point right there. That's the relationship. So we can then say, therefore, which points on the graph of f, the points on the graph of f are the turning points. Okay, they have the same x values as the x-intercepts of this quadratic graph. That's what it is. Okay, and then the next question says, for which values of x will f be increasing? Okay, so now we can look at that. Also looking at this graph right over here. Remember, we have minus 2 there, and then we have 1 there. Okay, and we're talking about 9.1.4. For which values. So you can clearly see that graphically looking, you can see that the graph is actually increasing from -2 up until 1. Okay, so how do we write that? These are the values of x, okay, which are coming from starting at -2 and then ending at 1. Okay, so you leave it like that. That's just it. Nothing more, nothing less. Okay, and then the last question says determine the y coordinate of the point of inflection of f. Now, when it comes to the point of what you call inflection, so the point of inflection, okay, let's just write it down first, 9.1.5. Okay, the point of inflection, right, P O I, we know that this is, you take the second derivative of the function and you equate it to 0. And then once you equate it to 0, you solve for your x. This x becomes the x-axis, the x-intercept, or rather the x value, not the intercept, sorry, the x value of the point of inflection. If you want the y value, you must now substitute into the original equation. Okay, so this is the into original. This is the format that we'll be following. So first of all, let us get the second derivative. We know that the first derivative, as we solved it above, we got, come on, -6x squared minus 6x plus 12. Okay, that's what we got. Hope you remember that. We got minus, if I remember it by head, minus 6x squared minus 6x plus 12. And then now we're looking for the second derivative. Okay, so that's going to be minus 6 times 2 is 12, x minus 1 times 6 is just 6. Okay, so we take this, right? The second part is to equate it to 0. And then solve for x. We can see here that x is simply going to be, if I take this 6 to the other side, it's going to be 6. And then if I divide both sides by 12, it's going to be 6 over minus 12. Like that. The whole thing is going to be minus. So simplify this, x is just minus a half. Right? Wow, I've run out of space, so I'm just gonna continue over here and just carve out some space for myself. And I'll continue here. Okay, now that we've got that 12, remember the process is to substitute into the original equation, that 12. So that minus a half, we'll substitute it into the original equation. Now if we look up here, what's the original equation? It's minus 2x. So x, wherever there's an x, we put minus a half. That's cubed. Minus 3x, wherever there's an x, we put minus a half, right? And then that's squared. Plus 12x, wherever there's an x, we put minus a half. And then plus 20. Okay, now this will give us the y value that we're looking for, because remember the question said determine the y coordinate of the point of inflection, right? So they want just that y value, right? So if we put this in a calculator, we will get that value that they are looking for. Okay, so we'll put exactly as it is. Minus 2, open a bracket, it's minus, and then a half, right? 1/2, go to the side, close the bracket. And what are we doing? We are cubing this, right? Go downstairs. And then the next one is minus 3. Open the bracket again. It's 1/2. But hold on, what did we forget? We forgot the negative sign. Let's put a negative right there. Okay, there we go. Go to the side, close it. This time we are squaring it, and it's minus. And then the next one is plus 12. Open the bracket, minus a half, like that. Go to the side, close it, and then plus 20. What do we get? 27. We get 27/2. Or if we want this in decimal, it's also equals to 13.5. Now this is the y value that we are looking for. I hope you understood the process. Okay, now looking at this question, the next question, this 9.2. Now this question was cancelled, ruled out of the exam, so we will not be doing it because it's irrelevant. Okay, other than that, thank you so much for watching. I just want to appreciate you at this point. Please do like and subscribe on our channel if you are learning something over here, and I'll see you on the next question number 10. Okay, let's look at question number 10 now. It says the profit given by WX earned by a company to manufacture X bicycles per week is given by this equation here. Now, what's important to note here is that this equation is actually a cubic function, right? As you can see over here, that it's a cubic function. That's cubic, and it is negative. It's a cubic negative function, as you can see, right? Oh. Anyway, let's leave it like that. Okay, let's just say question number, it's only one question number 10, right? So it's given by WX is equals to minus x cubed. It's a cubic function, it's negative cubic function. The rest of the information, I'm just going to put it here, minus 250 x minus 2700. Right, now we have that. Now the question is, what should the weekly bicycle production be to maximize profit? Now whenever they talk about maximizing and minimizing, we are always going to go into the first derivative, right? And then solve for x. Okay, we take the first derivative and we equate it to 0, and then we solve for x. Okay, and then we solve for x. That's what we do. These are the steps that we will be following. But because now this is a cubic function, as you can see, and it's a negative one, it is, it's like that, where that's our minimum and that's our maximum, that turning point there, our maximum. So if we can find this maximum turning point, it will give us the maximum profit. If we find this maximum turning point. And this exercise of equating you know, the first derivative to 0, we are really just trying to find the x values of the turning points. Okay, and then we take those x values, they will give us the maximum. So let's do that. Let's find then the first derivative. Okay, so this one, it's going to be equals to what? It's going to be equals to minus 3x squared over 150. Okay, and then the next one plus 6x, and then the next one is minus 250. Now remember what I said. I said we'll take this, equate it to 0, so I'll put 0 there, and just to simplify, it's gonna be minus x squared over, how many times does 3 go into 150? Gee whiz, I don't know, but okay, because I have a calculator. I can put that in a calculator actually. So I'm gonna say 150 divided by 3, that's gonna be 50. Okay, I'm just simplifying this, plus 6x minus 250. Right, so all I did was equate this. Now what we have to do then is solve for, simply just solve for x. Right, now let's use our quadratic function, right, where that's a, that's b, and that's c. Okay, and our quadratic function, if you remember, just to show you over here, there it is, it's minus b, and b is 6 in this instance, plus or minus the square root of b squared, which is 6 squared, minus 4, and a is minus 1 over 50, right? And then c, the value of c is minus 250. Cool. All this is under a square root and also divided by 2a. A is minus 1 over 50. Okay, so we need to put this in a calculator. There we go. Put that. We have minus, and then we have a 6. Let's start with the plus. Square root, open, it's 6, close, square that, minus 4, a, which is minus 1 over 50, just like that. Go to the side, close it, open another one, then it's minus 250 there, close it, and you go downstairs, it's 2 times minus 1 fraction, put 50 there, go to the side, close it, and that's equals to, so I can then say x is equals to 50. All right, or x is equals to, now what we have to do, let's go upstairs, go to the side, and change that positive there, make it negative, subtract that, 250. Get that, it's 250. Now if now I have a, you need to think about this, where is my maximum? Remember that our negative graph is like this. The small number should be on the left, which is 50, And then the bigger number should be on the right, because 50 comes first when you're using a Cartesian plane, starting from 0 going to infinity. So it's 50 and 250. Okay, cool. So then we can conclude then and say, therefore, our maximum profit is, okay, 250. Now I need to go back to the question to, you know, see what they were talking about. What should the weekly bicycles? So we're talking, remember, X is the bicycles, right? X is the bicycles, and they're asking what should the weekly bicycle. Read the English. So it's 250. X represents bicycles, so it's 250 bicycles. That's it. Please like and subscribe to our channel. We will really appreciate it. Thank you so much. We are almost there. We are now in question number 11. Well, let's just read it. It says machine A and machine B are two different coin pressing machines that operate at the same time. Okay, when it comes to these types of questions, we need to read the English and understand what the question wants. And in reading the English, there are certain words that we need to pick up that will be that will give us clues on what to do. Anyway, let's continue. The probability that machine A only has an implication presses a 5 Rand coin is X. Okay, I see it on my Venn diagram over here. This is a Venn diagram. Is X, and the probability that machine B only, once again, presses a 5 Rand coin is 0.3. I see it over there. Okay, the probability that both machines press a 5 Rand coin at the same time is 0.1. Okay, that's the intersection. I see it over there. I also see a Y right there outside, which means that neither of these events are occurring. Okay, let's go to the question. Now, if A and B are independent events, that's very important. We need to highlight that because it has implications. Determine the values of X and Y. Now, what do independent events mean? Okay, now that's a very important clue. First of all, we know that in independent events, the intersection is equals to the probability of A multiplied by the probability of B. So how does that look? We say the probability of A. How do we write intersection? We say and B. This word and means intersection. Now that's equals to the probability of A multiplied by the probability of B. Okay, that's the condition for independent. Now we're going to use this in condition to see if it can help us calculate. Now, what is the intersection? Do we know what the probability of the intersection is? Yes, we are given over there. It's 0.1. Okay. So we're just going to plug it. We're going to say 0.1. That's going to be equals to, what's the probability of A? Now, there's something I want you to look at. The probability of A. when we look at the probability of A, we are looking at the entire circle, which includes the intersection. So when we look at that, it's actually x plus 0.1. That's very important to understand. Times the probability of B. Now, when we look at the probability of B, likewise, we're looking at the entire, right? The entire circle. So the probability of B then is, I'm going to say 0.1 plus 0.3. Okay, it's very important to understand. Now we can just do the gymnastics. That's 0.1 there. Let's just leave this one for now. Plus 0.1. What's 0.1 plus 0.3? That is 0.4. Now what I want to do is multiply it in. So I'm going to say 0.4 times x. I get 0.4x. 0.4 times 0.1. Now I don't want you to make assumptions of this, so I'm going to use the calculator. 0.1 times 0.4, and then we get, let's put it in decimal, plus 0.04. Okay, now I'm gonna leave the 0.4x this side, and then I'm going to take this one to the other side such that it is 0.1 minus 0.04. And what do I get? I get 0.06. And then what is x? Therefore, x is equals to 0.06 divided by 0.4. Let's see what we get. I'm just going to say divide by 4, and 0.4. And then what do we get? We get that x is 0.15. Okay, now we have just solved for x now, but remember the question said solve for y as well. Now, how do we get y? We know that y is outside the events A and B, but if we add up all the events, the sample space is always equals to 1, because there's no probability that's greater than 1. Okay, so we need to add up all of these and equate them to 1. Okay, let's go for it. We're going to say x plus this 0.1, the intersection, 0.1, plus this 0.3 there, 0.3, plus this y outside. Okay, and all of that is supposed to give us 1. All right, we can substitute now. We know what x is. It's 0.15 plus 0.1 plus 0.3, that's 0.4 if I add them up, plus y is equals to 1. Therefore, my y is equals to, now I need the calculator once again. I'm going to say 1. Now, if I take these numbers to the other side, they become negative, right? So it's 1 minus 0.15 minus 0.4. And then what do we get? Let's change it to decimal. 0.45. Now that is our y value. Right. Okay, let's move on so swiftly. The next question, it says determine the probability that exactly one of the machines is pressing a 5 rand coin. Okay, so the English word there, that gives us a clue is this exactly 1. What does that imply? Now, we know that if we are considering probability of, A or B, normally you take the whole of A plus the whole of B. But if they say exactly 1, what that implies is that, let me just get rid of this. What that implies is that instead of taking the whole probability of 1, I'm going to take the probability of A only. Instead of taking the whole probability of A, I take the whole probability of A plus, also I need to take the probability of B, right? The probability of B as well, only. Okay, which means I'm going to exclude the intersection. That deals with this word, English word, exactly 1. Okay, right. So let's put it under a calculation over here. So this is now 111.1.2. So that probability then is just going to be x plus the probability of only B, which is 0.3. Now for x, we already know it's 0.15 plus 0.3. If we put that in a calculator, let's do it. 0.15 plus 0.3, we get, what do we get? We get 0.45. Yeah, that is our probability that we get exactly 1. Just like that. Okay, now let's move on to the next question. Now it says Wilson takes a driver's test. This is a completely different question now. It has nothing to do with what we just read above. The probability that he will succeed on his first attempt is 3/7. Okay. For each attempt that he redoes the test, the probability of passing increases to 3/5. Now, once again, you need to read the English and understand the question. Okay. Now, we know, or maybe you don't know, that if a test is repeated or there's repetition in the event, then we employ what we call tree diagrams. That's a clue. Okay, if something is repeated, then we use a tree diagram for that probability. Okay, so now over here, let's do a tree diagram. 11.2.1. Okay, we'll just start with 2 levels because 2 levels, it's the minimum for repetition. But let's see the question. What is the probability that Wilson will succeed after 2 attempts? Yeah, so that means yes, 2 attempts, we need to do a repetition. Our tree diagram must have 2 attempts. So here we go. What is it doing? Determining proper where are we? Driver's test. I'm just gonna call it DT for driver's test. Now, the probability that he passes, that's the first level, and then we'll have a probability that he fails. I'll put an F for failure. So the probability that he passes, let's go back to the question. The probability that he will succeed in his first attempt is 3/7. So we have 3 over 7 here. And then if the probability that he passes is 3 over 7, what's the probability that he fails? These are complementary events, okay? Meaning what's left is 3 over 7. What's left is 4 over 7. Why 4? Because 7 minus 3 is 4. You know, an entire sample space gives us 1. We've spoken about it even in the previous question. So if we've used up 3 over 7 to pass, it means it takes 4 over 7 to fail. Right. Now let's go back to second level now. The probability that he passes on his second attempt versus the probability that he fails. Okay, now the question says, if we go back to the question, don't make an assumption that it's gonna, because it was 3 over 7, it's gonna be 4 here. No. Let's go back to the question. The question says, if you read it carefully, for each attempt that he redoes the test, the probability of passes increases to 3 over 5. That he passes, okay, that English word, that he passes. Okay, so how do we put that here? That means for passing is 3 over 5 over here. Okay, 3 over 5. Now remember that its complementary event must be 5 minus 3, which gives us 2 over 5. Okay, same over with the failure. Okay, if we complete that branch there, it's either he passes, okay, or he fails. So the probability that he passes, once again, over here is 3 over 5 as given, okay? And then that he fails is 2 over 5. That's the complement. Cool. Now I hope you understand this. Now let's go back to the question. What is the probability that Wilson will succeed after 2 attempts? Now, you need to understand the English once again. You see, the maths is easy in this topic, but the English, that's the tough part. You need to understand the English. For him to succeed after the second attempt, it means he failed on the first attempt, right? And now only on the second attempt he passes. So on our tree diagram, the path that we follow is this one, that he fails and then he passes. That's the one that we follow, okay, on the tree. Okay, if you don't like to write it like that, then write it like this. This first level here is pass, pass. So pass, pass. This one is pass, fail. Pass, fail. This one is fail, pass. Fail, pass. And then the last one is fail, fail. So fail, fail. Okay, look at that. And then the question, the one that it wants, is the one that he passes on the second attempt, which means he failed on the first attempt, and then he passes on the second attempt, which means it's this one that I've highlighted there. Now, for that one, the probability is 4 over 7. Remember, we multiply the probabilities at this point times what? 3 over 5. Okay, that will give us our final answer. Let's get a calculator. So it's 4 over 7, okay, times 3 over 5. Does that give us? Gives us 12 over 35. So 12 over 35. That is our final answer for 11.2.1. Okay, now let's look at the second question. 11.2.2 says determine the probability that will succeed after 3 attempts. Oh, that means now we need a third level on our tree diagram. Okay, so I'm just gonna have to rub all of this because now that's not the path that we need. We need to make an addition. Okay, so on the third level, this would then be the probability having after oh, I rubbed this one here. I need it. That's pass fail, pass fail. Third level looks like this. It's a pass once again, and we've got a fail. Even here, we've got a pass and a fail. Even for this one, we've got a pass and a fail. Even this one, we've got a pass and a fail. Now, remember the English. The English says for each attempt that he reduce the test, the probability of passing increases. So because of this, it means even for this level, the probability that he passes is 3 over 5. Doesn't change. Pass 3 over 5. Doesn't change. A pass is 3 over 5. Doesn't change. A pass is 3 over 5. Okay, and then a fail now is, what is it? 2 over 5. Fail is 2 over 5. A fail is 2 over 5. A fail is 2 over 5. Okay, now understanding the English again, it says that he will succeed after 3 attempts, which means on the first 2 attempts he fails, right? So let's go and highlight that and see what that looks like. So first attempt he fails, right? So we follow that path. Second attempt he fails again, follow that path. And then the third attempt, now he passes. Okay, so we are looking for that one where now he is failing, he fails, and then he passes. I hope that makes sense. Okay, now let's do the calculation. Just follow the tree. First attempt, he fails, so that's 4 over 7 times. Second attempt, he fails again, so that's 2 over 5. And then the last attempt, he passes, so that's now 3 over 5. Multiply those. Let's get a calculator. First one is 4 over 7. Go to the side, times 2 over 5. Go to the side, times 3 over 5. That's gonna be equals to 24 over 175. Now that is our final answer. Well, tree diagrams, that's it. I hope you understood this. Remember that probability, the mathematics of it is easy, but it is the English that is tough. So we need to understand English for this topic and the implications of certain English words. Okay, well, that's it for now. Let me see you on the last question, question number 12. Okay, let's look at the last question now. It says, when Marge turned 8, her friends Emily, Clara, Corey, Lisa, Shirley, and Penny were invited to her birthday party. Marge and her friends sat in a row and played a game. In how many ways can they be seated if they sit in alphabetical order? Okay, so alphabetical order, if we look here, there is M, there is E, there is K, there's C, there's L, there's S, there's P. Okay, none is repeated. So there's just one way. Simple as that. 1.1. There is just one way. Or if they sit in alphabetical order, that's like from A to B. But also they can sit in alphabetical order from Z to A. So you could also say two ways. That's acceptable. Okay, so both answers are correct. You said one way, you get the mark. You said two ways, you also get the mark. Okay. All right, so let's look at the next question. 12.2.2. Now, Emily and Clara do not want to sit next to each other. Now, remember, probability, the maths is easy, but it is the English that is a bit hard. They confuse us with the English. There are certain words that characterize certain conditions. Like, for example, in this one, they say not. Okay, whenever you see this word not, they even wrote it in capital letters. That means we are really dealing with the complement. Okay, that's like saying probability. Remember, complement says the probability of something happening plus the probability of something not happening is equals to 1. Okay, that's what complements are. So whenever you are dealing with a not, you want to say 1 minus the probability of that event happening. Okay, and this is the situation that we are going to be dealing with right now. So what's the event here? The event is that Emily and Clara, the event is that Emily and Clara sitting together, but because of this word not, it means we will then apply the principle of complements. So let's go ahead. How many of these kids are there's Marge? 1, 2, 3, 4, 5, 6, 7. So we've got 7 seats. We go 1, 2, 3, 4, 5, 6, 7. Cool. Now, what is the probability that Emily, remember the event is that both of them must sit together, right? That's the event. So them sitting together, it's like if they take the first 2 chairs, they're sitting together there. Okay, that's the first 2 chairs. So how many ways can they sit together? There's only 2 ways. It's either Emily sits here and Clara sits here, or Clara sits there, then Emily sits. So There's only two ways that they can sit together. So we will say 2 factorial because it's 2 times 1. Now, now that we're done with, there's only 2 ways they can sit together. How many 2 ways can they sit together? Okay, for that, we'll have to use the colors. So either they sit the first 2 chairs or the second 2 chairs, like that. Okay, or they can also sit the third 2 chairs, like that. No, that one you can't see that one. Let's use a more definitive color. Let's go, I don't know, purple. Right. Okay. So you see what's going on here. I'm taking 2 chairs. So first 2 chairs, second 2 chairs, third 2 chairs. Now I'm gonna go to, you guessed it, the fourth 2 chairs. Okay. And then the fifth 2 chairs, right? Which are these fifth 2 chairs? And it looks like the last ones will then be the sixth 2 chairs, like that. So you can see here, how many ways can they then sit in this arranged order? So if we count, so this was 2 factorial for 2 ways, but how many 2 ways are available? There is 1, okay, 2, 3, 4, 5, 6. And this 6 can also vary, which means it's 6 factorial. Okay, so 6 factorial. But remember, it would end here if this was the event. If the question was Emily and Clara want to sit next to each other, it would end right here. Okay, but because of this word not, it means we're dealing with the complement, which means therefore we need to then subtract, you know, the probability, because what we just solved is that. So to get that probability, we then have to say minus, which is that minus over there, and the total. Remember, total probability is 1, but total probability for this scenario is not 1, because how many ways can they sit? There's 7 chairs. 1, 2, 3, 4, 5, 6, 7, and it's 7 factorial. That's the total probability. Okay, so this then is the probability of them not sitting together. Okay, right, let's put this in a calculator. Fortunately, our calculator can do these calculations. So it's 7, and then you have to look for your factorial. If I look at my calculator here, you can see it right over there in orange, which means I must press shift and then press, that's factorial, minus 2 shift factorial, it's orange, times 6 shift factorial. What do we get? 3,600. That is our final answer. Okay, I want to see something. If I removed this times and I put it exactly as it is, as I wrote it, would it still give me? No. I need to put the multiplication sign right over there. Okay, So that is then our final answer. Cool. Let us move on to the next question. This one says the probability that a certain rugby team has all its players fit to play is 70%. The probability that they will win a game if all their players are fit is 90%. When they are not fit, the probability of them winning becomes 45%. Calculate the probability of them winning the first game. Okay, so like we said before, probability is really a topic of, what shall I say, a topic of English. The maths is easy. It's the English they trap us with. So if we read this, let's write it step by step. What question number is this? 12.2, right? Okay, so 12.2. What are they saying here? Let's take it. Now, the probability that a certain rugby team has all its players is 70. So the probability that all players are there, all players is 70%, right? And then that by definition means that the probability, the complement of this, of not all players fit to play is therefore 30%. That's a complement because you say 100 minus minus 70 to get 30. And then it says, the second line says the probability that they will win a game if all the players are fit is 90%. So coupled with that, them winning, the probability that they will win under these conditions is 90%. Okay, which means the probability that they will not win under these conditions is, I can actually do a tree diagram if I want to, honestly, because now under these same conditions, the probability that they will not win is equals to 10%. I can do a tree diagram, but okay, this is for the condition of if all of them are fit, all players are fit to play. But if they're not, let's see then the third one. When they are not fit, the probability of them winning becomes 45. Okay, so over here, the probability that they will win becomes 45, which means the probability that they will not win under these conditions, what's for 100 minus 45, that should be 55. These are percentages, right? Okay, so this is the second condition, right? Yep. Okay, now calculate the probability of them winning the first game. Winning the first game. Okay, so this has to do with the first game. Okay, so we can see that they can win the first game in two ways. Okay, either just to follow, you follow this one, you see, they win there. If all are present, are fit, they win 90%. But also, you can see this is the other one, the other path that we can follow. They also win there. You see, they win. Win, win. Win, win. Okay, just like a tree diagram. This is actually a tree diagram, if I'm honest. It's just I put it strangely right now, but it is a tree diagram. Yeah, it's a tree diagram, right? So what am I doing? Okay, so the probability then of that, the first one is 70%. I follow this path, which is 70%. Okay. Times them winning is 90%, right? And then I need to add this one plus it's 30% times 45%. Okay, it's a tree diagram. I'm just following the path of them winning. No, I'm not concerned about them not winning, just winning. All right, let's bring in the calculator. So the first one is 70%. So I'm gonna go 70. Where's my percentage sign? There it is, and it's orange, which means I should hit it, the orange shift button, and go 70% times 90%. Let's go again. Plus, adding that probability, which is 30% times 45%. Just like that. What do we get? What is that? Okay, now remember, this is a decimal, 0.765. But if I want to convert it to a percentage, I have to say times 100. Then I get it is 76.5. Let's get more space here. Percent. That is my final answer. Okay, well, I hope you understood everything that we just did. But in the event that you didn't, well, you know what to do. Just contact us. We'll be more than willing to help you in any of these topics that we've done today. Okay, in this paper, we have concluded the whole paper. We hope that you learn much, and please do not forget to subscribe to the channel, like this video, so that the algorithm on YouTube will get on and pass this paper to many other students who will be looking for this revision before their test or exam. Okay, other than that, I so appreciate you. We appreciate you here. Thank you so much. See you later.